Hello children, welcome to channel Sube. Children, today I am going to discuss question number 21 from the MCQ part of 2018 Physics new syllabus paper. In the circuit shown, value of each capacitor is 1 microfarad. When the capacitors are fully charged, the total charge stored in capacitors is first one 2 microcoulomb, second one 4 microcoulomb, third one 5 microcoulomb, fourth one 8 microcoulomb, and fifth one 10 microcoulomb. Children, to solve this problem, first of all you should know how current flows along these resistors, the path. Across these capacitors there's no current. Any of these capacitors there will be no current, because after fully charged we are considering the situation. So until while it is being charged, the current is passing here, but you don't have to calculate those things in this class. Those things are calculated in higher physics, such as in universities. But here in A-level paper you have to do the calculations after fully charged, the condensers or the capacitors after fully charged. So then there is no current through these capacitors. So at that moment, that means electrostatics, this at statics, at static state you have to calculate. That means the capacitors are fully charged. After fully charging, there will be no current through these capacitors, only the current is there through these resistors. So if you draw the current, the path of the current flow, so the current comes from the battery and passes through these resistors, and again another path is there through these resistors. The current pass and go back to the battery, and there's another path, current from the battery flows through these two resistors and go to the go back to the battery. But here there will be no current. Here also there will be no current. Here also there will be no current, because there is a capacitor. Capacitor means in that capacitor there are two plates separated, not connected by insulators. So through that insulator current can't go. Therefore there will be no current through these capacitors. That you should remember, that you should know. To show that, and also you should know the lesson we learned in the topic current electricity, called potential dividers. If you know potential dividers, this will be easier. If you don't know potential dividers, this will be rather difficult. But it will not be difficult as that much, because this one is not a complicated potential divider. This one is a simple potential divider. Therefore you may be able to understand even though you don't know potential divider. So however, I am going to show you an animation, so that you will be properly understand even though you don't know those theories. So let us watch that now. So this one is the animation. So here the same circuit is I have copied to this animation, and there are two batteries I have used, 9 volt and 1 volt battery. Suppose this battery is 1 volt, because I have to supply 10 volts here, because in the question they have used the 10 volt battery. So somehow I have given 10 volt to this circuit. So the path along which the current flows, you can see as I explained. The animation is that. So now we are going to measure the voltages, potential at these nodes, and also voltages across these resistors. So the voltmeter negative is connected to the negative side of this battery. Already it is connected, and positive side we are going to connect to these nodes from time to time and measure the voltage. The maximum reading is 10 10 volt here, from 2 to 2 it goes, so you can get an idea how the voltage is distributed through these resistors. So now let us run this animation. Now we have connected the positive side of the voltmeter to the upper end of this resistor, bottom one. So the voltage is, the reading is 2 volt. 2 volt. Why we get 2 volt? Because altogether 10 volt is given to this circuit, 10 volt. So there are how many? 1, 2, 3, 4, 5. 5 resistors are there, each are equal, having equal resistance. So the voltage is distributed among these resistors equally. So the total given voltage, the 10 volt, is divided into, therefore, 1, 2, 3, 4, 5. So 10 divided by 5 is 2 volt. So each resistor gets a voltage equal to, therefore, 2 volt. So across this one there will be 2 volt, and across this one also there will be 2 volt, across this one there will be 2 volt. Because this one is the lowest voltage, that means the negative side of the battery, so we denote it by 0 volt. So we use this symbol, that means earth. So from that line, from that 0 volt level, we the voltage increases until this line, because this one is the positive side of the battery, that means 10 volt is here. The voltage along this line is 10 volt because it is connected to the positive side, that means the highest voltage given by the battery. So relative to this negative side, so negative side we don't use the negative meaning of negative, the negative word we don't use that, even though the polarity is called negative. We measure voltage respectively to this relatively to this 0 volt. This one is the reference line, and this one is the reference line. So relative to 0 volt we measure the potential. So since the voltage difference is 2 volt here, 0 plus 2, here the voltage is potential is 2 volt, and again another 2 volt is added to this this node, and here the voltage is then 4 volt, and here 6 volt. Like that voltage increases until 10 volt, here the top most line. So this one is 8 volt. So like that voltage increases from the bottom line to the upper line one by one when we pass these resistors. So that is what I am going to show you. Now the voltage is 2 volt, that is obvious. So now let us disconnect, and voltage, the voltmeter reading is 0 because it is not connected, the positive side is not connected. So we have written here indicate 2 volt that we measured. Now we connect to the next node, and here we see the voltage is 4 volt. Voltage is 4 volt because there is another 2 volt gap here across this resistor, and 2 volt here previously, and altogether 4 volt. Now here at this node the voltage means potential, we say potential. Potential is 4 volt. Now we have written it there. Then 6 volt, as I explained, 2 by 2 potential increases, and finally 10 volt, the upper line is 10 volt because directly it is connected to the supply. So that is how. Now you can, I think, understand how voltage is distributed along this line. 2, 4, 6, 8, 10, like that. From 0 we start. The lowest voltage is here because we have connected that to the negative side, so we consider this line as 0. Consider this line as 0. Now let us check the voltage along this path, this branch. That also 2 volt. That also 2 volts because the same amount of resistors are there, 1, 2, 3, 4, 5, same number of resistors, 1, 2, 3, 4, 5. So the total voltage fed into this circuit is 10 volt. So that 10 volt should be divided by this 5. Then we get the voltage across one resistor, that is going to be 2 volt. So like that. This question is not a difficult one because they have given equal branches like this. But this one is different. This one has 2 resistors, so then total voltage should be divided by 2, since the number of resistors are used are 2, number of resistors that are that used are 2. So therefore we have to divide the total voltage given to this circuit, that is 10 volt. 10 volt should be divided by 2, then we get 5 volt. So at this node the voltage will be 5 volt, here 10 volt. So let us see it. Here 5 volt. The needle is in between 4 and 6, so that means 5 volt. Right. Now I think you understood how voltages are there in this circuit. So children, let us mark those voltage values. Here the potentials 2 volt, here 4 at this junction, node 6, here 8 that we don't want, because there's no node, there's no branches. So here 2, here 4, here 6 at this point 8. Let us mark this also 8, and here 10, and after that here again 10 because the battery voltage is 10. Here 5 because divided by 2, 10 divided by 2, since there's 2 resistors. So children, now we have to take the voltage. What we have to find out, first of all, checking the total charge stored in capacitors is. So individually we have to find the charge of each. So Q equals CV, you know that equation. This one is what now we are going to use. So C is already given 1 microfarad, so 1. So we don't have to multiply it by 10 power minus 6 to convert into farads, because the answers are given in microcoulomb. So you have to just use this one. Let us solve in microfarad and microcoulomb. So the capacitors each are 1 microfarads. So 1 times the voltage here, let us consider first this one. The voltage here is what? This one, 4 minus 2. 4 minus 2 is 2. So the voltage difference, potential difference is 2. So we have to substitute here potential difference. So therefore 2 times 1 is 2, then microcoulomb, that much. So let us now consider this one. What is the voltage difference? What is the potential difference? Potential difference, here the potential is 6, here also 6, there's no difference. So here we have to substitute 0. Then what we get? 0 microcoulomb. Therefore we don't have to worry about this one. It has no charge stored. So this one, what is the voltage difference? Not minus. What is the voltage difference? 8 minus 5. At this node it is 8, at this end it is 5. So 8 minus 5 is the potential difference, that is 3. So we have to multiply 1 by 3. 1 is coming from this one, 1 microfarad. The capacitance is 1 microfarad here. This one is 1. So the voltage difference is 3. So 1 times 3 is 3 microcoulomb. So the other one is 0. This one is 0. Then 2 plus 3 is 5 microcoulomb. The answer is this one, obviously. Third one. Understood? Easy as the way I explained, using even animation. So I dedicated, remember. So children, here is your target question. I changed the question a little bit so that you can solve it. Now try, pause the video, As you have paused the video, now I am going to solve this. So let us find out the potentials at each nodes, that means voltages. So the battery is 10 volt. First of all, you have to examine the EMF of the battery given, and then you have to examine the available paths on which the current flows. So it is the same, 3 paths are there. And also you have to check the number of resistors, whether they are equal in value, and also the number of resistors in that line. Then you have to calculate the potential difference in each resistor, dividing the voltage given, battery voltage, by that number of resistors. So here there are 1, 2, 3, 4, 5 as previous. So 10 volt is given to this 5 volts. So each one gets 2 volt. Here also 1, 2, 3, 4, 5. So the same voltage, 2 by 2 by 2. So the potentials at this place, 2, here 4, here 6, here 8, here 10. So like that, 2, 4, 6, like that. We don't want those things because there's no nodes here. Only at nodes we have to find out. So here 5 volt. 5. Now let us take the voltage difference of each. So let us take first this one. So it has 2 here at this end, 2 here at this end, 4. 4 minus 2 is 2. So 2 volt is the voltage difference for this condenser capacitor. 4 minus 2, here 2, here 4. At one end the potential is 4, at one end the potential is 2. So the difference is 4 minus 2 is 2. So still the capacitance is 1 microfarad. So therefore we don't have to use that. Just the voltage is equal to the charge, because Q equals CV, where C is equal to 1 microfarad. Therefore we get directly Q equals V. Therefore 2 microcoulomb is stored here. 2 microcoulombs is stored here in this condenser. So this one, regarding, I use green color, this one has voltages, potential here at one end 6, this one, the other end 2, because both are connected to the same node here, 2. Then 6 minus 2 is 4. For this one voltage is 4, then it has 4 microcoulomb. Then this man, 6 minus 5, 1, 6 minus 5, one end is 6 at potential 6, one end is at potential 5. Then 6 minus 5 is 1, so 1 microcoulomb it has. Then 4, 5, 6, 7, altogether 7 microcoulomb. This one is the answer, fourth one. Now easy, isn't it? Okay. So children, here is the next target question. Try this, pause the video first, and on your own, honestly do it without looking at my answer. So as you pause the video, I am going to start. So voltage is the same, the number of resistors are also the same. So 2 volt here, 10 volt here, then 2, 4, 6 volt here, then 0 here, 5 volt here, 5 volt here, the same voltage, because there's no resistors, extra resistors, only the first one we have passed, and in between, even we have not gone to the second resistor, we have not passed that. If we pass this second resistor, the voltage will be 10. So in between these two resistors, all the points has 5 volt potential. So therefore this capacitor has 5 volt at both ends. Therefore there is no potential difference. 5 minus 5 is 0. Therefore we don't have to consider this one. It has no charge stored. It has no charge stored. So according to Q equals CV, the voltage is 0. Therefore no Q. So therefore we can forget this. And we have to consider this one, 10 minus 2. 10 minus 2 the voltage, then 8. So Q is 8 microcoulomb. Since this one is still 1, otherwise you have to multiply it, remember. So this one has 6 minus 0, then 6, then 6 microcoulomb altogether. Then 8 plus 6 is what? 9, 10, 14. So this one is the answer, second one. So children, here is the next target question, number 3. Children, here is the next target question, number 3. Try this on your own. Pause the video now. As you have paused the video, now I am going to try this. So the battery voltage is now not the previous, 20 volt now. So there are 4. So let us mark the voltages. 4 resistors, 4. Then 20 divided by 4. Since these values of resistors are equal, each R, therefore 20 divided by 4 is 5 volt. So here 0, this one 5 volt, at this node 10 volt, at this node 15, here 20, everywhere 20, here also 20, this line 20, 0. Then 2 resistors here, 20 divided by 2, 20 divided by 2 is 10. So at this node the voltage is 10. After this one 20. So 1, 2, 3, 4, 5. 20 divided by 5, because 20 is fed into this line. Then 1, 2, 3, 4, 5 resistors are here. 20 divided by 5 is 4. So at this place 4, at this place 8, at this place 12, like that. So let us first take this one. Still the capacitance is 1 microfarad. Then we have to find out the voltage only. Then that equals to the charge, because Q equals CV. So if the C is 1, just Q equals V. Therefore let us try this one first. What is the voltage? 15, 0. 15 minus 0 is 15. So 15 microcoulomb must be there. Then using green color I do this one. So at this end the voltage is 12, at the other end the voltage is 0. Then the difference is 12. Then there must be 12 microcoulomb stored in that condenser capacitor. Both words are used. So here 10 at this end, and here 20 along this line it is 20. Then 10 here, 20 minus 10 is 10. Then 10 microcoulomb must be there. Altogether 15, 25, 35, 36, 37. This one is the answer, first one. Okay, understood? Good. Children, here is your target question number 4. Try this on your own without looking at my answer. Pause the video. Right, since you have paused the video, now I am going to start. So let us mark the potentials. So the battery voltage is 20, so divide by 4 here, then 5 10 15 20, then divide by 1 2 3 4 5, this 20 volt is given to this line, the negative line is this one. Negative means 0. So everywhere 0 here, everywhere 20 here, so like that. Then 20 is given to this line, to this line 20 is given, because the battery is very close to that, it is connected at this both nodes. So divide by 5, 1 2 3 4 5, therefore 4 volt, here 4, here 8, that we don't want, 4 is enough, 4 8 12 16 20, like that. So there are only 2 resistors here, 2 resistors, then 20 divided by 2 is 10, here 10, here 10, here 0, here 0, here 20 again, that we don't want, only the close to the capacitors we need. So now take this one first, take this one first. Remember, note this one is now different, 2 microfarad, we have to multiply by 2 to get the charge. 2 times C is 2, 2 times V. Then what is the voltage here for this condenser, for this capacitor? 15 here, 15 minus 4 is 11. Then the answer is 22 microcoulomb in that capacitor. Then let us take this one, it has 10 volt here, 10 volt, and at the other end again 10 volt, at the end like this 10 volt, that is the other end, 10 volt, 10 volt, 10 volt. What happens? No charge, because there is no potential difference, no difference, equal, potentials are equal, therefore there is no difference, then no charge, then we don't want to bother about that. So this one, now 10 at one side and 0 at other side, then 10 volt, 10 volt times 2, 20, altogether the sum is 42 microcoulomb, 42, this one, fourth one is the answer, right. Let us wind up the video now, finish.